Right, so I'm going to go over the practice quiz, and you can do as you wish with it. Do as you wish with it, as far as use it to help you prepare for the test. So let's go through this logic puzzle. So Jane won and wore red. So Jane's first place. And she wore red. So we can put that down here. Jane first red. Then it says the girl wearing number 1 came in third. So there's number 1. Oh, sorry. Third place, number 1. Now, obviously, Jane couldn't wear number 1 because she came in first place. And the red does not go with third place. Yeah, we should have put that down. First place goes with red. What I meant is that red doesn't go with number 3. Sorry, red does not go with number 3 because sorry. I know what I'm doing. Red does not go with number 1. I got it. All right, Julie beat the girl in yellow, but wasn't wearing number 2. So Julie's not wearing number 2, and Julie could not take 4th place because she beat somebody. And since she beat the girl in yellow, she wasn't wearing yellow. Now, the girl in yellow could not have taken 2nd place. She could take 3rd potentially, or 4th. And yeah, Julie can't take 4th. And red. Okay. All right. Only one girl finished in the same position as the number she wore, but she didn't wear red. So we already know that, right? She took 1st, but she didn't wear number 1. Jackie beat the girl wearing number 3. So Jackie didn't take 4th because she beat somebody, which means Josie took 4th place. So Josie 4th. And so Jackie beat the girl wearing number 3. So Jackie doesn't wear number 3. And she doesn't take 4th. Okay. I might be missing something. Probably am, but we'll keep moving. The girl in green wore number 2. So green, see number 2, green. So just looking here, so we know that Jane wore red and took 1st place. She doesn't wear number 1 because number 1 came in 3rd. She doesn't wear number 2 because the girl in green wore number 2. It says Jackie beat the girl wearing number 3. So she doesn't wear number 3 because she took 1st, so she didn't get beat by anybody. which means that Jane must be number 4. Right, so one more time. She doesn't wear number 1 because it says the girl wearing number 1 came in 3rd. She doesn't wear number 2 because that was the girl in green and she wears red. It's not number 3 because Jackie beat the girl wearing number 3, which means she wears number 4. So Jane wears number 4. Okay, so that's done. All right, so we had the girl in green wore number 2, and Josie wore yellow. So here's Josie, she wears yellow. And we know Julie beat the girl in yellow. So let's just, hold on, let's go down here, 4th yellow. Right, so we know Josie was in 4th place. So 4th place goes with yellow. Yellow goes with 4th place. And we know yellow's not number 2 or number 4. So Josie can't wear number 2 or number 4. The girl wearing number 1 came in 3rd, but Josie came in 4th. So Josie can't be wearing number 1. So Josie must have worn number 3. Right? So he says the girl wearing number 1 came in 3rd. Josie came in 4th. So Josie wears number 3. All right, so that means that Jackie wears number 2 and Julie wears number 1. All right, so we go looking up here, the number 1 took 3rd place. So Julie must have taken 3rd because she wore number 1, which means Jackie takes 2nd. And then colors, the girl in green wore number 2. So we know that Jackie's number 2, so she was in green, which means that Julie is in blue. So you can fill out the logic puzzle, but this is the answer you should get. And I like clue number 7. A spectator remembered one girl wore blue, but couldn't remember anything else about her. Okay. Logic puzzle, Lewis Carroll style. So we got to have a single statement that includes all 5 of these. So the first step is to change these all into conditionals. So interesting poems are popular among people of real taste. So I'll just use an I for interesting and a P for popular. So if the poem is interesting, then it is popular among people of real taste. The second statement, no modern poetry is free from affection. So what that's saying is if the poetry is modern, then it has, sorry, not affection, affectation. And affectation is, means like when you're trying to impress, sometimes even being fake. Okay, all of your poems are on the subject of soap bubbles. So if it's your poem, then it's on soap bubbles. So y equals your poems, and S equals soap bubbles. I've never read a poem on soap bubbles. No affected poetry is popular among people of real taste. So if it's affected poetry, then it's not popular. So that goes here. And then lastly, no ancient poem is on the subject of soap bubbles. So remember the clue up here, ancient means not modern. So if the poem is not modern, then it's not on soap bubbles. All right, so there's your list of statements. Now we got to combine these, and we're going to use the law of transitivity. So law of transitivity and the law of contrapositive to do that. So first I'm looking for transitivity. So anywhere where I see like if A is B and B is C, then A is C kind of a deal. And I see here we've got M is A, and A is not P. So I can combine those two to say, I'll do that over here. M is not P, right? M is A is P, not P, sorry, M is not P. Okay, so now I'm looking and I've got I is P, Y is S, not M is not S. So and then M is not P. So I don't have any other transitivity opportunities unless I use contrapositive. So let's use contrapositive here. And so this is the same as if we wrote S implies M. Okay. So now we have we have Y implies S implies M implies not P. So we use the law of transitivity here. Y is S is M, so we get Y is M. So now we have I is P, M is not P, Y is M. So we have Y is M is not P. So these will cancel to give us Y is not P. So now we got to use contrapositive one more time. We're going to flip this one. So it says not P implies not I. And so Y is not P is not I. So we combine the two and we get Y is not I. And so Y means your poems and not I. I was interesting poems. So a statement would be your poems are not interesting. And that is the statement I'm looking for. All right, indirect proof here. Oops, sorry. So we are given measure of A equals the measure of C. And we will show triangle ABC is not scalene by proof by contradiction. So, okay, we assume that triangle ABC is scalene. By definition of scalene, all sides are not equal. All right, so that means AB is not equal to BC. Sorry, not equal. It's not equal to AC. All right, so now we look at what we were given. We're given that a measure of angle A is the same as measure of angle C. So we got to try to come up with a contradiction here. So I'm going to use the converse of it-bat. Since the measure of A equals the measure of C, by the converse of it-bat, that's the isosceles triangle base angles theorem. So the converse says if two angles in a triangle are equal, the sides opposite them have the same length. So by the converse of it-bat, BC, the distance from B to C, equals AB, the distance from A to B. Right? Because the angles are the same, the sides opposite them must also be the same. So you could do this, you could take it one step further. You can say because I have two sides in this triangle are the same, it's isosceles by definition. And so it can't be scalene and isosceles at the same time. That's a contradiction. Or you can just say, because we have this statement here, BC is AB, and then looking back here, we wrote that BC is not AB. So we can say, therefore, this triangle must be isosceles by definition, and a triangle cannot be both scalene and isosceles at the same time. Sorry. That is a contradiction. So our assumption that triangle ABC is scalene is false. Thus, we have shown triangle ABC is not scalene. All right, so that's what I'm looking for. You need to have all these parts. You need to state the given, what you're going to prove. You need to say you're proving by contradiction. You need to say what you're assuming. You need to use logical steps using definitions, properties, postulates, and theorems to come to a contradiction. You need to tell me what that contradiction is. And then you need to say that your assumption is false. And then you need to say what you have shown. All these things are needed to get full credit. All right, consider the following conditional. If you don't ride in a car to school, then you ride on the bus. Well, actually, no one goes to school anymore. So I wrote this question back in the old days when people actually went to school. Huh, fancy that. All right, what is the converse? So remember, converse is Q implies P. So you just switch. So if you ride on the bus, then you don't ride in a car to school. The inverse is not P implies not Q. So the inverse is if you do not ride in a car. So that's a double negative. So we say if you ride in a car, then you don't ride on the bus. Right? Because you got to negate both parts. And the contrapositive is not Q implies not P. So if you don't ride the bus to school, then you do ride in a car. Right, because you got the double negative again here, right? Then you do not. So, all right, another little logic puzzle here. Sorry, just trying to focus it a bit better. My saucepans are the only things that are made of tin. So if it's made of tin, then it's my saucepan. So T equals made of tin. S is saucepan. Then it says, I find all your presents very useful. So if it's a present from you, that means it's useful. So P is present, U is useful. Then the last one, none of my saucepans are of the slightest use. So if it's my saucepan, then it's not useful. All right, again, we're using transitivity and contrapositive. So T implies S implies not U. We can combine to get T implies not U. Now we have P implies U, T implies not U, and we use law of contrapositive to switch this to say not U implies not P. So now we have T implies not U implies not P. So we can combine to T implies not P. So if we put that into a statement, if it's made of, things made of tin are not presents, are not your presents, but let's switch that around to make it sound a bit better. So we'll say P implies not T. Your presents are not made of tin. So there's your statement. All right, Karen and Andrew will each visit a different Great Lake this summer: Superior, Huron, Erie, Michigan, or Ontario. So here's Kara, here's Andrew. Put the homes. They're homies going to one of the homes, right? Huron, Ontario, Michigan, Erie, Superior. So it says they will not go to Erie or Ontario. No Ontario, no Erie. No Ontario, no Erie. Andrew will visit only Superior or Huron. Superior, Huron, not Michigan. Well, he don't know what he's missing. Carroll will visit Michigan if Andrew visits Superior. So you got if Andrew visits Superior, that means Kara visits Michigan, right? So if Andrew visits Superior, then Kara will visit Michigan. Andrew will not visit Huron if Kara does not visit Erie. So this would be Kara not visit Erie. If Kara does not visit Erie, then Andrew will not visit Huron. So if you flip this using the contrapositive here, you would get Andrew visits Huron. If Andrew visits Huron, then Kara visits Erie. Okay, so Andrew visits Huron, Kara visits Erie, and if Andrew visits Superior, Karen visits Michigan. So we know this can't work because Kara is not going to Erie. So he can't go to Huron, so he must go to Superior. And so this says, if Andrew visits Superior, then Kara will visit Michigan. So she must visit Michigan. All right, if the conditional false, then the contrapositive also has to be false because they go together. That's the law of contrapositive. All right, last question. It's time for knights and knaves. You know I love a good knight and knave puzzle. This one's a little bit tricky. Nothing above your pay grade, but let's take a look here. Okay, so Zippy claims at least one of the following is true. Bill is a knight or Alice is a knave. Alice tells you Bob is a knave and Zippy's a knave. Bill says Alice is a knight. Bob says Bill is a knave and I am a knight. It's a bit complicated. So I don't know who you want to start with. You kind of start by making an assumption. It's kind of like a proof by contradiction, right? You make an assumption, and if you get to a contradiction, you say, oh, this can't be true. So if you say Zippy's a knight, it's a bit tricky because either one of these is true or both of them are true. So maybe we can try Alice, because if she's a knight, then both of these have to be true. So let's try that. Alice is a knight. So we're assuming here. What happens if we assume Alice is a knight? Well, she says Bob is a knave and Zippy's a knave. So logic would follow. If we're assuming Alice is a knight, Bob would be a knave and Zippy would be a knave. Bill says Alice is a knight. Well, Alice is a knight. We are assuming that to be true. So therefore, Bill would be a knight in this scenario because he's telling the truth. Bob says Bill is a knave and I am a knight. Now, Alice said Bob's a knave. So under this assumption, Bob's lying. Bill is a knave. Well, Bill's a knight. So, okay, that's a lie. That fits. Then he says, I'm a knight, which is obviously a lie if he's a knave. However, the one little trick here is could Bob be a knave and say, and Bill be a knight? Sorry, and Bill be a knave. Because for this to be a lie, only one part has to be false, right? If Bob says Bill is a knave, and Bill really is a knave, but he also says I'm a knight, that's still a lie if he's a knave. So that's a bit tricky. So can we definitively say that Bob's lying? He could be a knight or a knave in that tricky scenario. However, if we go back up to Zippy, Zippy says that at least one of the following is true. Bill is a knight or Alice is a knave. Well, Bill is a knight, so he's telling the truth, right? Because only one of these has to be true. Both can be true, but only one has to be true. Bill is a knight in this scenario. So Zippy's telling the truth, but Alice, who has to tell the truth, said that Zippy's a knave. So this cannot work. This cannot work because you got a contradiction. Zippy can't be a knave and be telling the truth at the same time. Now you could go and say, well, then Alice must be a knave, but this gets tricky. So if she's lying, it gets that same problem we had with Bob, where she says Bob is a knave and Zippy's a knave. Well, only one of those has to be not true for her to be lying. So from her statement, Bob could be a knave or a knight, and Zippy can be a knave or a knight, right? It's just that they both can't be knaves. So one of the two has to be a knight. We just don't know which one. Bill says Alice is a knight. Well, obviously, if we're assuming Alice is a knave, now Bill is a knave because he's lying. Bob says Bill is a knave and I am a knight. Well, okay, both those things could be true. If Bob was a knight and Bill is a knave, then Bob would be a knight. But Bob could also be lying, right? If Bob says Bill is a knave and I'm a knight, if he was a knave, this is still all a lie. So we can't definitively say that Bob's a knight or a knave from his statement. And then Zippy says Bill is a knight or Alice is a knave. Well, we're assuming Alice is a knave. So we know Zippy must be a knight. But that coming back here, Alice tells you Bob is a knave and Zippy is a knave. Well, we know Zippy's a knight. We just showed that. But that doesn't necessarily mean that Bob has to be a knight. They could both be knights, or one of them could be a knight, and Alice would still be lying. So we know he's a knight. I guess I don't need to write it down here. But we still don't know about Bob. And so this is kind of a dead end. Because of those and statements are a bit difficult. So what if we try Bob? So what if we say Bob is a knight? All right, if Bob's a knight, then Bill is a knave. So this was a dead end here because we couldn't tell definitively what Bob was. So assume Bob is a knight, then Bill has to be a knave, and Bob says, Bill's a knave, I'm a knight. So Bob's a knight. Bill says Alice is a knight, but he's a liar. So that must mean that Alice is a knave as well. Alice says Bob's a knave and Zippy's a knave. Well, she's lying. Bob's a knight, but that doesn't tell us about Zippy, right? It's that and conundrum. One of them is false, makes the whole thing false. We don't know about Zippy, but Alice is lying because we know Bob's a knight. We're assuming Bob's a knight, and she says he's a knave, so she's a liar. So take a look at Zippy. Zippy says at least one of the following is true. Bill is a knight. Bill is not a knight. Or Alice is a knave. Alice is a knave. So Zippy is a knight because he's telling the truth. So we go back to Alice's statement. Alice says Bob is a knave, lie. Zippy is a knave, lie. Turns out they're both knights. So this works. Bob's a knight, Bill's a knave, Alice is a knave, Zippy's a knight. So hopefully that's what you got. And if you have any questions, let me know.